Morning everybody, and welcome to the RedShark segment of the NAB TV show. I just want to make sure I say thank you to Teradek, who are hosting this, and they do a fantastic job. They're famous for this big glass cube TV studio. We can see everything that's going on from here, but I just want to say how much we appreciate all the effort that Teradek put into this, because it's a huge effort hosting a multi-camera globally streamed TV show with fantastic quality, I'm told. I mean, the whole essence of Teradek is producing quality streams, and they do a great job, as you can see. So I'm here this morning with Greg from G Technology. I would say almost certainly the top company in storage technology for production and for video and for audio.
Sure.
And they're constantly innovative, and they have great industrial design as well. It's always hard with storage because people imagine you can put stuff together in your garage, buying parts off the shelf, but honestly you try doing that, making it look good, distributing it globally, guaranteeing it for 5 years, and you can't do it. So I'll talk to Greg about maybe what's new. What are you showing that's new here?
Yeah, just as Ken, you mentioned, G Technology continues to be focused on building high performance and stylish and reliable storage products. At the show here, we're announcing our new Thunderbolt 3 solutions. We've put that new interface and that new connectivity into our G Drive Thunderbolt, our G RAID with Thunderbolt, and then now our high capacity, high performance G Speed Shuttle XL with Thunderbolt 3. So we're very excited to have those products in the portfolio, taking advantage of that really fast, high-performance interface.
And is this Thunderbolt 3, does that take the physical form of USB-C?
That's correct, yeah. The physical form is that Type-C interface, and then you can apply different protocols to that. So we're using the Thunderbolt 3 USB-C interface connection.
And what effect does this have on performance, moving to Thunderbolt 3?
A much bigger pipe to be able to move data. We're doubling the rate, going from 20 gigabits per second to now 40 gigabits per second. The other great thing about Thunderbolt 3 is that it also supplies the a video stream as well. So now we can also support higher resolution monitors and displays and other really video-centric kind of peripherals as well.
So how do you do that? How do you get video out of a disk drive?
Yeah, so we've done some unique things. Specifically on our G RAID with Thunderbolt 3, we've actually used some of the video connectivity and added an HDMI port onto the back of that, which is a really great solution. Excuse me, really great solution that enables us to put an HDMI 2.0 port on the back of it that allows us to support video monitors, 4K, 60 frames per second, and also the high dynamic range monitors that are out there and available in the market today.
So just so I understand the topology of this,
sure.
You'd have, let's say, a laptop, Thunderbolt 3, would go into the drive,
correct.
And then you plug your monitor into the HDMI on the drive.
Exactly. So yeah, if you come and visit us at our booth down in South Hall, we have a MacBook Pro, a single Thunderbolt 3 interface on it. That's actually a part of a larger daisy chain, with the G RAID being a part of that. So we have a G Drive Thunderbolt, the G RAID Thunderbolt, and even the G Speed Shuttle XL, all a part of one connection. And then, as you pointed out, we actually have an HDR monitor that's coming off of that G RAID with Thunderbolt. Specifically our friends at Adamus, who have their nice 7-inch monitors that are a great tool for that post-production side.
Yes, of course. I'll come back to the Atomos integration in a minute, but I just want to just mention that I still have to pinch myself to understand that you can have a cable about the size of a shoelace, and you can send all of your external data, all of your storage, all of your video down this single cable. It seems unreal, because I remember in the early days of SCSI drives, you'd have a cable about the size of a hose pipe, a massive parallel connector, and the wind had to be in the right direction. And if that connector wasn't pushed into this massive parallel port properly, the whole thing wouldn't work.
Yeah.
And we've just moved on, so it's all virtually hot plug and play, isn't it?
And as you mentioned, I mean, it's truly the interface that will do it all. As the Thunderbolt Consortium will say, it's the port, the interface that does it all. It does video, does data, it does power.
Yeah.
I mean, it just has a.
So you can power your laptop from the drive.
Yeah, a variety of different devices will supply that power. We have one of our solutions that provides 45 watts using the USB-C interface. And so there's some unique things that you can start to do, and we're excited about it because being part of a much larger company that has a lot of innovation and technology, we're able to apply that now into storage products that can do these unique, differentiated things, but also provide high performance and high reliable storage products.
Can we just focus in on that?
Yeah.
Because again, for the people that say you could build one of these in your garage, you use high performance drives, don't you? You use enterprise level drives.
That's correct. And these three new products that we've brought to market with Thunderbolt 3 use the HGST UltraStar Enterprise Class hard drive, one of the most reliable drives on the planet. And that's been a lot of the success of G Technology has been about building reliable products, and we have the technology that we can put into our products that really can bring that reliability to our customers.
So I guess in a sense all of this is immensely, well, let's say transportable as opposed to overtly portable. You've got your portable products like the USB-C SSD drive,
yes,
and you've got the ruggedized drives.
Yep.
Which I remember when I reviewed that, I threw that in my bathtub.
Yeah.
And but you know, even if you're doing heavy duty 4K editing, you can take your entire rig with you now.
Yeah, I mean, a lot of people will bring that G-RAID with Thunderbolt, and they can bring that along with them, right? And that can be used to obviously offload all of the footage from that day's shoot, and then when you go back to the hotel, you have now that storage you can actually begin to edit off of.
Yeah.
Even the Shuttle XL, we designed it to be transportable.
Yes.
Integrated handle. It's a small form factor that actually can fit within a Pelican case that you can bring along with you, or even check underneath the airplane. So we've done a lot of things to really look at building efficiency around the workflow and how people are using storage in the field as well as back in the studio. Yeah.
Let's talk about capacity at the moment, because as we move towards 8K in multi-versions, you know, graded, ungraded, you get just the data multiplies exponentially.
Massive, yeah.
What kind of capacity can you deal with in your systems?
Yeah, so that's a great point. We basically, again, being a part of a larger drive company, we now have access to 12 terabyte hard drives, 3.5-inch base media. So in that Shuttle XL, for example, we can now have 96 terabytes across 8 drives, massive amounts of data that people can bring with them. We just worked with one of our G-Team brand ambassadors, well, 2 of them, Vincent LaFerre and Lucas Gilman, who just did a project for us out in Iceland, and they were generating on average 2 to 3 terabytes a day, and they were gone for 10 days. You can do the math very quickly. A lot of data has to get stored and brought along with them, and not only have it be available, but also to be, have multiple copies of that, right? So capacities are obviously need to grow along with the higher resolution and the higher frame rate and the high dynamic range. All combined requires high performance, high capacity storage.
So let's talk about Atomos.
Sure.
How you? I know you're now making drive, the insertable drives.
Yeah. So we partnered up with Atomos. Again, we want to be as close to the capture phase as we can.
Yeah.
And so not only with Atomos, we have that relationship with Red. We also have a CFast reader. People that have high performance camera media need to offload that very quickly into higher capacity storage. So our partnership with Atomos is great because we have access to really high quality SanDisk flash and really high quality 2.5-inch base media, and we're able to work with them and integrate that into our ecosystem, our Evolution Series ecosystem, which is all about workflow and optimizing that.
And this is it's an incredibly versatile system, because essentially if you make an adapter, you can plug almost any kind of storage medium into it, and then it's right in the center of this ecosystem, working at full speed. Very flexible system.
And that's it, right? We're creating a flexible, expandable ecosystem of products that can all work together. Out in the field, on set, back into the studio, into post-production. And from portable 2.5-inch base media with solid state spinning discs to these unique partnerships that we develop with Atomos and Red, and then building our own CFast, we can do some really, really amazing things.
Okay, fantastic. Greg, thanks ever so much.
Thank you, Dave. Appreciate the time. Have a great NAB.
Pleasure. We'll be back in a few minutes. We'll be talking about Lytro, which is arguably one of the biggest innovations in this industry for decades. Very excited about this. See you in a minute. Hi everyone, welcome back to the RedShark segment of the NAB show. Very excited that we've got Buzz Hayes here from Lytro. I don't know if you remember last year, we had headlines that looked like a typo. We were talking about sensors with a resolution of 755 megapixels and abilities of this camera that sounded like they were straight from science fiction, but it is absolutely real, and I can't wait to ask you what have been the developments since last year.
Sure. Well, since the announcement last year at NAB, we've been working with Foundry on the software tool side of it, because as you can imagine with workflow, the file sizes you're dealing with are pretty massive, and so the infrastructure and workflow needs some careful consideration, especially if we wanted to fit into commercial product like Nuke's Foundry, the Nuke product from Foundry. So we've been working with them since early last year on software tools. We'll have a plug-in set available later this year that allows visual effects artists to manipulate the light field data just like we demonstrated at the show last year. We've also been doing some upgrades on some of the camera hardware. So we have a brand new version that will be ready later this summer. We're just about finished with the calibration on that, and it's looking amazing, as you can imagine. We've been beefing up the hardware infrastructure for recording. The system, as you mentioned, it's a 755 megapixel sensor, and if we're capturing at the full frame rate of 300 frames a second, we're capturing 300 gigabytes per second. So we have a massive
Sorry, can we just pause there? 300 gigabytes per second?
Yes.
So it's a terabyte roughly every 3 seconds.
Yeah. So we have basically a massive server farm that we capture from, and we have the other big development we've had since last year is we put the camera, you saw the physical size of the camera is still quite large, because honestly the science is easier to work out on that scale.
Yes.
The sensor is 500 millimeters wide, a little over 500 millimeters wide. So we're working out the rest of the science before we get to a miniaturization state. But in order to make it more portable, we also commissioned the development of a crane system for it. So we're using a motion control crane by the folks from Sorensen, and it glides like a Steadicam now, even though the thing is the size of a small automobile. It glides like a Steadicam. So we've been putting a lot of work into the support mechanism behind it to just make it a very usable camera in its current configuration.
Okay, well let's just rewind a bit. For people who are not familiar with the concept, it has some incredible abilities, doesn't it? I mean, we'll talk about those in a second, but essentially the biggest practical use perhaps is in CGI and VFX, where you have a completely volumetric idea of the space of the scene in front of you.
Exactly.
And of course this enables pixel accurate integration with CGI models.
Absolutely, yes.
Yes.
And so what we've also have this year is we have a tool called LFA, Light Field Animation. It's basically the CG component to this. So imagine shooting live action with light field.
Yes.
We get the live action foreground, and then we're going to put in CG background to that. We now have the tools to be able to render out the full CG background in light field, so that when we composite the two together, the entire scene is now light field. It's the equivalent of being basically a very detailed color hologram of the scene, where we can change parallax within the scene. We can rack focus now between the live action elements and the CG seamlessly. So we can treat it as one light field, even though the sources came from different places, all the way through to composite.
I'm sorry I keep pausing here, but there's so much that is incredible about this. I think it is necessary to pause, again, for people who are not familiar with the concept. One of the best illustrations is the fact that you can do green screen work without a green screen. I think you had an illustration where you actually had a car park where you'd normally have a green screen, and yet the keying was absolutely perfect.
Yes, because basically what we're recording is every light ray in the scene.
Yes.
It's XYZ coordinates plus the angular information.
Yes.
So we know exactly the origin of every light ray in the visible field. So with the depth screen tools that we have, we can basically isolate any given light rays and then just essentially turn them off. So we can take any distance from camera and just make that a transparency now without the need for green screen. And we have very accurate depth information, both from the calculations that create the light field images, but also from some active depth sensing units that we have on the camera that are correlating the actual depths to the calculated depths to make sure that we have very precise depth.
So do you call these volumetric pixels?
That's been one of the terms we use.
Yes.
Yeah, I mean, we tend to just refer to everything as a light ray in this case,
yes.
As a three-dimensional object or a vector.
That ultimately is what the reality is, isn't it? Pixels are like an artificial construct within that.
Exactly.
Yeah.
And so this gives 3 dimensions to a pixel, not only in its space, but in its origin and its trajectory. And I think that information becomes useful for things like, one of the things that we're working on is the ability to relight a shot after it's been photographed. So you can actually add fill light or change the adjustment of the key lights after it's been photographed, because we have all of the vector information from every light ray in the scene to begin with.
Okay, now one of the things that we tend to focus on in RedShark is we look further ahead than most publications,
Sure.
because it's fun, and I think it's necessary
Sure.
to understand where we are, to understand what might be coming up. And so it seems to me this is part of a wider category of computational imaging.
Absolutely.
And there are 2 main branches, I guess. There's light field, and there's like the kind of multi-lens thing that you're seeing with the Light L16 camera. But I think surely much of the development over the next few years is going to be in this software space, where
Yes.
the software is interpreting the quintessentially the nonsense that is coming off the sensor. Yes. Nonsense in the sense that it would be to us if we saw it raw, and turning it into something that is meaningful.
Yes, absolutely. And the amount of computing power required to work in light field is pretty enormous.
Yes. Yeah.
So one of the things we've been doing, and what we announced here at NAB this year, was we've been working with Foundry on a project called Elara, which is basically their cloud services platform, where you're running as many instances of Nuke as you need in the cloud, and you can run it from a browser on a laptop.
Wow.
And we've enabled the system in partnership with them to allow for these massive file sizes, but anyone working with a browser on a laptop now has access. So we can have teams of visual effects artists unencumbered by location.
That's right.
Be able to work with these massive
and to anybody
file
with
sizes.
limited broadband, which is a typical domestic experience, this may seem fanciful, but over the next few years we're going to have 5G, we're going to have multi-gigabit speeds, wirelessly, so this will become routine.
Well, what's interesting is for the data that we capture, we process that data in the cloud and bring back from the raw light field, we bring back our dailies. But at that point, because the data lives in the cloud, all you're really downloading to the computer is the user interface.
Yep.
That's it. So a 10 megabit connection will work.
Once you get your head around that topology.
We need 10 gig to get it up there, 10 meg to bring it back.
That's it.
down.
Once you get your head around that topology, it makes complete sense,
so
doesn't it?
it's a different way of thinking, and productivity changes dramatically.
Yeah.
But more importantly, we can empower artists from all over the world to work together on things that normally they would have to be in the same physical
So for
location.
everybody who says, "Oh, that will never happen," the answer is, it is happening.
It is. Absolutely. It's gone from science fiction to science fact.
That's a good note to finish on. I mean, we've been talking for what feels like 10 seconds, but it was actually 10 minutes.
Yes.
Buzz, ever so nice to meet you.
Pleasure,
Thanks very much indeed. Thanks, everyone. Bye.